I'm going to welcome to the stage Binoy Das, who is from AWS, who's a solution architect who works with clients and partners to bring forward the state of machine learning and the state-of-the-art technologies. And is going to talk to us a little bit today about how day-to-day AWS is helping their customers bring a breakthrough through AI. So take it over, Binoy. Thank you.
Thank you, Ryan. Hello, everybody. Well, Ryan already introduced me, so let's jump right in. So talking about the breakthroughs, I think you guys are all here learning about one major breakthrough that happened about 20 years back. And that breakthrough is in the area of machine learning. Now, I'm not going to go into the details of the history of machine learning, how the machine learning went through the sort of the hype cycle and how it has matured. But I was reading this book called Master Algorithm, written by Pedro Domingos. And what he argues that there have been 5 different tribes, which is basically the 5 different ways that scientists have tried to solve this problem of coming up with a master algorithm. And so far, our industry, we have seen one breakthrough, and that is in the area of deep learning. But that single breakthrough has been so transformative that everything we see around us happening today, all the possibilities that the other speakers are talking about, or you will see at some of the booths done by Solstice and other companies, they are all based on single major breakthrough that is in the areas of deep learning. And that is so transformative that it is touching all the industries today, right? Starting from autonomous vehicle, the smarter agriculture that you heard about, predictive maintenance, the robotics, speech and sound recognition, right? I mean, today you can talk to a machine just like as you would almost like to a human, to your smart speaker, video security, and all these different areas. Now, the challenge in democratizing the machine learning, what we find from our customers' experience is oftentimes reaching the end devices, the devices that in your hand today. It could be your mobile phone or that tiny camera on your dash cam or that security camera that is up there on a traffic light or an airport, everywhere. So in AWS, so what we do is we work hard to solve these hard problems for our clients. So as a broad overview on AWS Cloud Platform, we enable our customers to train machine learning model with a large-scale data set that they already have on their cloud data lake or data warehouse. Then once the model is trained, that state-of-the-art vision model or the natural language processing model, customers often want to deploy that onto that edge device. It could be your iPhone, your Android phone, your Raspberry Pi, and so on. And that is where they find difficulties because when you train your model, in a training framework like MXNet or TensorFlow or PyTorch or whatever you use, and then you want to deploy that model onto one of these target devices, our customers find that it is not often a straightforward process. And before jumping into the technicalities, let me give you an example. So think about, instead of those 3 frameworks at the left, think about me and my 2 other colleagues, right? So I am a native speaker of Hindi and I speak English, right? My colleague Rumi, she's a native Japanese speaker and she speaks English as well. And then my colleague Luciano, he's a native Portuguese speaker, but he speaks Spanish and English as well. Now, as part of our job as solution architect at AWS, we do have to go and meet clients and talk to partners in many different parts of the world, many different geographies in the world, right? Starting from North America, LATAM, Europe, Asia Pacific, and Middle East. Now, what happens is, when that happens, now we have to divide our time, who gets to go and be more effective in which geography, right? For example, I can go to some countries in APAC and in North America. Rumi can go to Japan, maybe China, and Luciano can cover more of the LATAM side. Now, imagine if you want to have these group of this team of solution architect more effective, you would have to now teach everyone to speak every different language that our audience, that our customer is speaking. And that is always a big problem. And this is not only a problem at the human scale, this is also at the machine scale. And the reason I'm talking about this is when you have your model trained in one of these machine learning framework, and then you want to deploy in a multitude of devices that will be running closer to where you are actually doing the intelligent work. As a machine learning practitioner, you now are expected to understand all the CPU architecture, the code base that runs, the memory size, the instruction size of all those devices. But as a machine learning practitioner, you are not supposed to learn all of these because that's a completely different domain, mostly optimized by the dedicated hardware engineers. But how do you do that? Yet when you work for your organization, you are expected to become a full stack data scientist. You are expected to train the model and hand the model over to the downstream team who will be using the model in their downstream application on their devices. So how do you do that today? So it turns out that doing this kind of optimization is sort of a black art in itself, right? So there is no one size fits all approach. What you have to do is you need to take the model, you need to strip off the model from the framework, because what happens is all of these frameworks on the left-hand side of the screen, these are great when it comes to training the model, because it gives you a very convenient high-level interface that allows you to do your training much faster. You do not actually have to do and write a linear regression or logistic regression code with a gradient descent yourself. You don't have to do that today because the frameworks takes care of that for you. But what happens is what happens in the framework stays with the framework. So without this kind of tuning, that intermediate step, now you have to bring this whole bulky framework onto these little devices that are often constrained on memory and CPU. That makes your models very slow to run, or sometimes you have to resort to a much simpler model in order to have a very fast speed of inference from your device. So what is the middle ground here? So as a middle ground, what we can do is basically what people have been doing for ages using compilers. So if we go back a couple of decades, when this programming language called Java came out, the promise that Java brought into the market is basically write once, run anywhere. So Java uses a virtual machine that takes your source code and converts it into an intermediate format that can then run on multiple different target hardware. So today in machine learning on AWS, what we have done is we have created this open source framework called SageMaker Neo, which changes this many-to-many problem to one-to-many problem. Now, what Neo does is it sits in between your training framework and your target device and works in a very similar way that a compiler works. So what it does specifically? So it does three different things to begin with. So the first is representation of the model in an intermediate format. So this is just conversion of the code into an intermediate format so that it becomes easy to analyze the code and fine-tune for the target hardware. Now, once it is represented in the intermediate format, then we do a bunch of other things by analyzing the structure of the network graph, the neural network that the model is representing. The first thing we do is called pruning of the graph. So by pruning, I mean cutting off some of the nodes in the graph that were helpful during the training stage. But we often find when it comes to generating inference, many of those nodes are not necessary. So the first thing is the Neo does is to intelligently look at those nodes that are not necessary for training and cut them off to make the tree size more compact. The second thing that we do is called layer optimization, where we look at multiple different operations that are happening together and combine them, merge into a single operation, which then makes it much faster, because now instead of sending 10 instructions, now you are doing 1 instruction. And another complementary state it also does there is called tensor optimization. So in machine learning, you must have heard these terms vector and tensor. So all this means is basically when you have a series of numbers to work on, instead of working on single numbers, you work with a group of numbers. So it does all of that to make it fit to the instruction for the target machine and creates a model that is optimized and runs up to 2 times faster on the target platform and about 10 times reduced memory speed. And the reason we open source this model is now all these partners can jump on to this framework and then create a target runtime for their devices. And that is how we are creating more value in this area by open sourcing this product, which, by the way, is also available on SageMaker platform as a service and as an open source platform. So that's all. And then I'll be back later with the panel to take any questions that you might have. Thank you.